Okay, so we keep on keeping on. Determine the non-permissible values of theta for this following identity. Now, in this case, this comes loaded with a lot of non-permissible values. We need to look at where both the 1 plus sine theta is equal to 0 and where the cot theta is equal to 0, or subsequently, since it's one of those reciprocal identities, we have to see where it's undefined as well. So starting off, I look at 1 plus sine theta, and we say this cannot equal 0. So my sine theta cannot equal negative 1. Well, where sine theta equal to negative 1, it's equal to negative 1 at 3 pi by 2, and then every 2 pi from there. So we say plus 2n pi, and then again we say where n is in the set of integers. The next one is we're looking for where cot theta cannot be equal to 0, but we're also looking for where sine cannot be equal to 0. Because again, we remember right here with my cot theta was cos theta over sine theta. So what this is telling me is that the cos can't be equal to 0, nor can the sine not be equal to 0. The cos can't be equal to 0 because, again, it's in the denominator there. And the sine cannot be equal to 0 because that makes it undefined. Luckily, from the question that we just did previous to this, if I look up here, I already have my solution preloaded. So theta cannot equal pi over 2 n, where n is in the set of integers. And I forgot to put the cannot equal on that one. Now, moving on, these next ones that we're getting into are kind of going to be our first case of doing some trig identities. Now, if to be an actual identity, there'd have to be an equal sign, but we're going to just work and try to simplify these. So express each of these as a single trig function. Doesn't matter which trig function it is. Well, let's start off. I have sine x, cosecant x, and cos x. So I have sine x, and then I know that cosecant x is equal to 1 over sine x, and then I have cos x. Well, what happens right here, I pull out the big red, and we go pop, pop, because we'd get the cancellation right there, and then this would give me simply cos x. Moving on to my next one. What we have right here is we have that sine squared x all over cos squared x plus 1. Well, we know that sine over cos is equal to tangent. So this would give me tan squared x plus 1. But what does tan squared x equal from looking at our formula sheet or from above? It equals sec squared x. Oh baby, cos squared x plus sine squared x plus cosecant squared x minus 1. Well, we go back to our good old pickup line right there. You're cos squared, I'm sine squared. Together we are 1. So I get 1 plus cosecant squared x minus 1. And then I get 1 minus 1, so that leaves me with cosecant squared x. Next up, we have 2 tan x all over 1 plus tan squared x. Now this one's going to take a little bit more time to get through, but we start and I go, well, it equals 2 tan x, and I look at 1 plus tan squared x, and 1 plus tan squared x is equal to sec squared x. Now from here, what we're going to do is we're going to reduce this a little bit further, and we're going to get 2 sine x all over cos x all over 1 all over cos squared x. And then that is going to equal, and I'm just going to take, well, I'll leave the 2 on top with the sine x, all over cos x. And then what we're going to do is divide that by 1 over cos squared x, which will then give me 2 sine x all over cos x. We kiss and we flip. And then, getting my cancellation, that will cancel the square with the cos x. And this leaves us with 2 sine x cos x. Now, technically, we did kind of break the rules because we were supposed to try to get this down to a single trig ratio. But as it stands right now, this is as low as you guys will be able to get this. This does also equal sine 2x, but we will get to that one later. So don't worry about that right now. Looking right here, express each in terms of sine x and or cos x. So I have tan x all over sec x, which is going to equal sine x all over cos x all over 1 all over cos x. Speeding through this a little bit more, that will give us sine x all over cos x, all multiplied by cos x. I get my big red and I go pow pow, and this magically will give me sine x. Looking at my next one, I have 1 plus cotan squared x. 1 plus cotan squared x is cosecant squared x, and then that's all going to be over the sec squared x. From here, this will give me 1 over sine squared x all over 1 over cos squared x, which will end up giving me 1 over sine squared x, and then we'd multiply that by cos squared x all over 1. So then this will take me to cos squared x all over sine squared x. Now, just because it said it wanted it in terms of sine and or cos, we would leave that as the answer, but you guys that are astute would also notice that this does equal cot squared x. Now, a question that some of you may be having right now is, how do I know where to start? How do I know where to stop? I want to assure you guys that we're doing this to give you guys a preamble as to how to do proofs. Once you get to the actual proofs, the start and the stop point is very, very clear, and it's very, very definite. This is a bit vague just because these aren't the type of questions that we're going to be doing, but this is a very important part of the types of questions that we are going to be doing. Okay, so we'll finish off the next one in the next lesson. I hope you guys have enjoyed.